Cool. Um, Sorry everyone for the trouble. Okay. I'm Rajashree and I have Nikos with me. So we both will be going over how we adopted AWS ECS Capacity Provider from a third-party vendor. So first of all, let me go through on like what we basically do at Sharethrough, so that gives you a perspective on why we need ASG and why we had a third-party vendor in first place. So Sharethrough basically is an ad tech company, which primarily is an ad exchange that connects the publishers and advertisers over the major demand sources like display, video, and native. So being an ad tech company, we operate at a scale of 1 million QPS or even more at some time. And also with that, we operate in 4 regions of AWS serving over 200 countries. And we have been partners with AWS since 2011. So with this scale, operating at this scale, we actually had to bring in the use of spot instances because we are based out on ECS, EC2 on ECS. So while bringing up the EC2 instances, we had the option to use both spot and on-demand instances. So with the on-demand instances comes with the high cost as well. So we had to opt out for the spot instances majorly. So we were utilizing a third-party solution since 2017, and that application actually provided us an exceptional service wherein it would enable us, wherein it enabled us to integrate ECS and that application. And whenever we requested the spot instances, that application was able to bring up the spot instances. And also, when the spot market was in a bad situation at some point in time, it would also switch over to the on demand instances as a fallback. So that ensured that we are mostly running on the spot. And only when there is a bad spot market day, we are going over to on demand instances. And this ensured that we saved a lot of cost on the instances, EC2 instances, because our infrastructure cost is huge. So to give you an idea, so in US East 1 region, we almost spin up 900 and almost 800 to 900 instances at a time, running more than like 2,500 tasks. So with that scale, if we just operate on on-demand instances, that would be a huge cost for us. So optimizing the cost is one of the major area which we focus on at all the time. So once, so why, so we, why did we choose to move out of this third-party solution? The reason was, of course, the cost, because they employ a pay-as-you-go model, wherein whatever instances we consume, we pay for that. And also, since they bring up the spot instances, it actually gives us a lot of savings as well, right? So they charge almost like 20% on the savings that we accrue. So that was not a big deal. Till now, as in we moved to ASG like 2 months back. So before that, it was not a big deal for us. But as and when we got to know about ASG, Amazon EC2 capacity provider, that's when we realized that it would almost save us $1 million per year, or even more than that, at the that we are operating at. So, next slide, please. So, how did ECS capacity provider benefit us over the third-party solution? So, with AWS ASG, it's so they charge you based on the spot instances and on-demand instances, basically on the utilized. So, how much ever we utilize, we are only charged on that. And also, we do not pay any charges on the savings that we do with the use of spot instances. So once we implemented this, we saw an savings of approximately 80 to $9,000 per month in our infrastructure cost, which is huge for us. And so that's why we decided to move ahead with the integration of ECS, AWS ECS, and AWS EC2 capacity provider on ASG. And also with the utilization of AWS EASG, we saw that we are also had a significant reduced instance provisioning time. So initially with the third party capacity provider, it was almost taking like 5 to 6 minutes to bring up a instance when we requested from ECS. But since this is like all in-house, AWS communicating within AWS, probably because of that, we saw a reduction in that provisioning time from 5 minutes to 3 minutes, which is a big deal for us. Since we auto scale at a larger, like very frequently, we auto scale because of the number of requests, impression requests that comes in. We need to scale as quick as possible. So this 3 minutes, the saving of 2 minutes is also a big deal for us. This ensured that we are able to bring up more instances and more tasks quickly than before, serving more requests at a single point of time. And also establishing this ASG infrastructure was a very straightforward process, wherein we just had to have a launch template and the ASG infrastructure setup, which was not a very complicated process in itself. Apart from that, we had like a bit of configuration issues while setting it up with Sharik, our TAMS. He helped us a lot in understanding most of the concepts there, and we were able to kind of spin up our ASG. And we tested this out in our staging regions first, and then slowly moved out to the production environment. So yeah, this was a long process for us, but then totally beneficial. So one of the drawbacks that we have with ASG was that we do not have an automatic fallback to on-demand instances, which I already spoke about, which we had with the third-party solution. And that's a very important part for us. So Nikos would be continuing on that topic and also explaining on how we implemented this ASG. Thank you.
Thank you, Raja. First of all, anyone that has worked with spot instances to save costs has probably ran into like bad spot market days where you just lose your spot instances immediately, basically pulling the rug from under your application, leaving it like in a bad state. So one thing that we had with that third-party solution was that in those situations, it would automatically fall back. This is something that with ASG and capacity providers, we didn't have, at least not seamlessly and automatically. There is the option to switch capacity provider weights, but that would trigger a deployment in your application, which can be very disruptive to the daily development processes. So what we did in our solution is we engineered a Lambda function along with it that will effectively circumvent this limitation. What we basically did was we are now using two separate capacity providers linked to their respective autoscaling groups, which are in turn linked to separate ECS services, both put behind the same load balancer, basically carrying the same load.
Nikos, you there? I think he
Just give
dropped.
him a moment.
Yeah.
We'll just give him a moment to rejoin. No problem.
Yeah. While he's joining it, just giving like sharing the context, what Nikos is sharing is that is the one of the primary reason any third-party spot vendors do come into picture. Like there is no default option in ECS right now where you can flip between on-demand and spot. So that's the crux of this presentation, how we've developed our in-house solution to flip between on-demand and spot instances on the fly. This is not something which is native offering right now in ECS. Rajashree, let me know if you want to take over or you want to continue while Nikos is running back.
Yeah, I can continue on this till Nikos is back. Anyways,
Sure.
so yeah, as Nikos mentioned, so in our architecture, initially what we had was ECS communicates with the third-party vendor and requests any instances, spot instances or on-demand instances, and the third-party vendor would provide us that instance. But now, since we have implemented ASG, so this is the architecture which we have followed as of now. And it follows, so we have an ECS cluster. So the ECS cluster basically, so here I say one ECS, but we actually have two ECS service. So one of the ECS service basically has Spot, and one of the ECS service is on demand. And also we have two capacity providers associated to them. So each of those services, ECS services, will have a Spot capacity provider and an on-demand capacity provider. And to give you in context, so both of these ECS services are connected to a same load balancer, so that whatever request comes in, it falls to this load balancer, and it gets distributed among these two services at the same time. Like whichever is running instances, it will just push those requests to those instances, be it Spot or on demand. So coming back to ASG, so we have two different capacity provider, one for Spot and one for on demand, and both are backed by their own ASGs, so auto scaling groups with their own launch templates. So the Spot ASG is supposed to bring up all the Spot instances, wherein we have set up the configuration to use 100% Spot. And similarly, the on-demand ASG, on-demand auto-scaling group, has 100% on-demand is set up as a configuration. So this ensures that we have either 100% Spot or 100% on-demand on either of the services. So now we also have a CloudWatch alarm, which basically lets us know when we have a bad spot market day. So since we have to fall back to on demand, we need to know when the spot market is really bad, so that we can switch over to the on demand. So at all time, the on demand instances would be 0, and we are running entirely on spot instances. Only when we have a bad spot market day, we are switching over to on demand. So yeah, so the CloudWatch alarm basically helps us achieve this. So we have created a CloudWatch alarm that basically tells us or alarms us when we don't have the Spot instances available for more than 20 minutes or so. And how do we identify this? We see if the desired capacity of the Spot service is more than the running capacity of the Spot for more than 20 minutes. And also we see that the ASG's auto-scaling group desired capacity and the instance capacity is like there is a difference between them for more than 20 minutes. And then we have a Lambda, which basically handles this situation. So whenever the CloudWatch alarm triggers, this Lambda would ensure to bring up that many difference of instances to the on-demand ASG. So let's say we have 10 desired capacity, 10 tasks of desired capacity, and we are running only 5. So we have a difference of 5. So we are going to bring up that 5 instances in on demand after 20 minutes. So that's basically what this Lambda does. And similarly, we have a logic in the Lambda which keeps checking the on-demand ASG and sees if there are some instances running there. And if it is, then it also triggers a CloudWatch alarm, which ensures that we bring back those on-demand instances back to Spot whenever the Spot market is stable. So we keep checking that. We keep checking if the Spot market is good or not. We try to bring up more instances to the Spot. If it's not able to bring up, then just revert it. If it's able to bring up, then we reduce the on-demand capacity. So this way, we are kind of switching back and forth between the Spot and the on-demand instances without compromising on the quality of service that we provide to our publishers and the advertisers. So yeah, so that's our auto scaling architecture that we have right now. And also, this is something which we implemented almost 2 months back, and we're still improving on it and looking out for some edge cases that we might face. So far it's been good, and ASG has been working really great for us. So since we have overcome that one drawback which we had, which is falling back to on demand. Nikos, do you have to say anything?
Yeah, apologies for that. I don't know what happened. It was not a good timing. I just wanted to add that not being too certain of the solution, we also implemented a notification to the Lambda where it notifies us on Slack on what's going on, whether it had to switch from on-demand to Spot or vice versa. And so far, those notifications have only been an annoyance, which is good. It works as it's supposed to, and everything is fine. But as Raja said, we are constantly trying to identify any edge cases that we may have missed here, and trying to monitor a variety of parameters in order to have this be safe for us. That being said, I would really like to thank Sharik for his support and the whole Times team for their support throughout all of this. They've been great help. So thank you, everyone.
Sure thing. Thanks, Nikos. Rajashree, floor is open to questions. Okay. In that case, I think, Eric, I'll pass it back to you.
I do see one question that just popped up. I can repeat it, or if you have visibility in the chat.
Yeah, I see it. I see it. Honestly, we haven't met a situation like this, but what we try to then, this is not related to our solution here, but what we try to do is we try to utilize at the largest variety of instance types and sizes. We run multiple tasks on larger instances just to make sure that we are trying to take up everything that AWS has to offer in terms of instance types and sizes in order to avoid situations like that. So I think we're currently using more than 140 instance types and sizes, both AMD and Graviton together, which has been a challenge to pull off, but it is working. So I'm happy to say we haven't ran into issues like that when on-demand is not available.
Just to add to what Nikos said, I think one more thing, just for those edge cases, is what we are looking for RIs also as a baseline. That's what is also in efforts. Like, we understand on-demand is not available all the time, but that's where a baseline RI, like RIs for the baseline, which are expected to be running 24/7, that is also something we are working as a analysis right now, working on analyzing if that can help us. So yes, that is also for those edge scenarios, which can happen once in a lifetime, I would say.
Yes, this is something that we are considering using arrays and running a certain percentage of our workload on on-demand instances at all times. And to answer Daniel's question about the cutover latency, there's really no issues for us there. Simply by tweaking the scaling thresholds for ECS, we make sure that even if there's no spot instances available, it's running safely up until the point where we decide that we need to run on demand and we start them up. So we haven't experienced any issues so far, but as we said, like, we are constantly tweaking and trying to improve the solution. It's fairly new to us, and I'm sure even though no one wants it, we'll probably run into issues sooner rather than later.
And I think, yeah, my first question answered Daria's questions also. We are working on a baseline. And yes, the idea is to use savings plan or RI for the baseline, where we are sure that we are not overutilizing or underutilizing it, just for the bare minimum instances, which can be run 24/7.
Yes.
Great. Well, last call for questions. If not, thank you so much, Rajashree and Nikos, for presenting today. And at this point, I think we're a little ahead of schedule. So this would be a good time to, thank you. It's be a good time to take a quick break. Actually, before we do, I see we got one more question that just came in. It says, how does it scale in large deployments?
So to answer that, we currently haven't really needed to make any changes, and our deployments are pretty large. And implementing this, we haven't noticed any big differences in our deployments. So it's being handled quite nicely. We have considered either pausing scale-ins during deployments, and a few other possible options that I just can't think of right now, but we just didn't really have to do that, and we didn't notice any change in our deployments.
Yeah, to add to that, yeah, we have a maximum deployment percentage to set to around 150 percentage, which ensures that we have that many instances available at the time of deployment. So this has been the same while we were using third-party solution as well. So after moving to ASG, we didn't make any changes to that part. So it's been going on smoothly with that.
Great, thanks. And another from Pete, who asks, what type of cost savings do you predict compared to using reserved instances?
I don't know if we have any numbers, Raja. Do you anything off the top of your head? I can't think of it, honestly.
No, I'm not sure about the percentage of cost that will get saved with using reserved instances. So the major purpose for using the reserved instances is so that we don't have to often call the Lambda that we have created to bring in this on-demand instances, and we have some instances always running without any downtime. So that's why we are kind of planning to have a reserved instances. But I'm like, for now, as of now, not sure on how much cost savings we will have with that.
So yeah, just to add, I mean, there are two components to it. When we are saying total number of EC2 instances, the workload is pretty high during the business hours. That is 8 hours of the day. So definitely reserved instances does not fit there. Yeah, for the baseline, I mean, if you're just looking for the baseline, like if we are comparing apple to apple, like 10 reserved instances versus 10 spot, then I think it's pretty much equivalent, the pricing comparison. But for this use case where the workloads are pretty uneven across the day, I don't think RIs will fit across for the whole set of EC2 instances, if that's what you're looking for. That's where the spot comes in.
And if I may just add a little bit to that, so even with spot instances, prices go up and down daily, and sometimes a spot instance can cost up to 90 something percent of the on-demand price, depending on the availability. So we are thinking of implementing even an additional solution to this, where we would track the spot prices daily or maybe even weekly and update a prioritized list of instances that we use, so that we put the one that are cheapest for us on the top, and maybe by that trying to save even a little bit more. But as Raja and Sharik said, the reserved instances are mostly there for our safety.